Hi everyone. Today we're going to be combining like terms. Imagine you're working at Stop and Shop. Your manager asked you to stock the fruit onto the shelves. Why do you choose to stock the shelves this way? So I know when I walk into a supermarket, I don't see all the fruits and vegetables all mixed. I see them separated by what they are. So what I'm going to do is I'm going to take all of my apples and I'm going to put them on one shelf. Then I'm going to take my bananas and go and put them on another shelf, and my oranges and put them on the third shelf. So I sorted them by what type of fruit they are. If we want to write an expression to represent this, if you notice, all of the apples are labeled x squared. So we're going to look and see how many x squares do we have. So I have 1, 2, 3 of them. So since I have 3, I know my apples will be represented by 3x squared because I have 3 apples labeled x squared. Now I'm going to look at my bananas, and each of those are labeled with an x. So I'm going to say I have 1, 2. I have 2 bananas labeled x, so I am just going to write here 2x, since I have 2 bananas labeled x. Now I look here at my orange, and there's only one of them labeled with the number 1. And I'm going to label right here just the number 1. That's a constant, and it's by itself. If I wanted to combine all of these to create one expression, I'll put them all together. Depending on what their sign is. Here, they all happen to be positive. So I'm going to take my 3x squared, and I'm going to add my 2x, since it's positive. If it was a negative, I would put minus 2x. And I have this positive 1, so now I'll write plus 1. And that's going to be my expression. This becomes 3x squared plus 2x plus 1. Here we're going to talk about the algebra tiles again. I know we've done this for the last lesson. We're going to represent each expression with the algebra tiles. Let me scroll down. And we're going to try to represent x squared plus 4x. So there's no number in front of x squared, so there's no coefficient there. So we know there's only one of them. So here's my x squared. Then I have my 4x. So I'm taking 4 x's. And now I have minus 3. So I look at my plus and my minus, and I know I need the minus. And I need 3 of them. So this is kind of like what we did with that last problem, talking about the apples, the bananas, and the oranges. You're just separating them by their categories and what they are. Now we're talking about combining our like terms. Here we're given this expression, 3n squared plus 2n minus 5 plus 4n squared minus 5n plus 4. When I'm combining these, I want to make sure I stick to, just like my apples and bananas, my variables. We want to make sure they have the same variable with the same exponent. And to combine these, I'm going to circle or square or put some kind of shape around the ones that I have in common. So right now I am going to choose color, and I'm going to look at my exponents first. So here I have a circle around 3n squared. So I look through the rest of my expression and I look for another n squared, and I see one right here. When I'm circling this, I want to keep it the same shape so it helps me to know what to combine. You want to circle it plus the sign that's in front. So here it has a plus 4n. So I know that this is 3n squared plus 4n. Now I'm going to go ahead, I'm going to change my color, and I'm going to look for a variable here. Now I have n that doesn't have an exponent. So now I'm going to I'll put a box around it. I have my plus 2n, because when we're making our shapes, we want to include the number that's in front. So the number to the left, I mean the sign, excuse me. And I have minus 5n. So this is telling me I'm taking positive 2n minus 5n when I combine those. Now I'm going to pick a new color. And I'm going to look for my constants. My constants don't have to be the same. A constant just means a number without a variable. So I am going to put a diamond. So here I have -5. Because remember, I use the sign next to the left. And I have my positive 4. Okay. So I can either combine these all together right now, or if it is helpful, you can write each one out. So I'm just going to match the color, and I'm going to start with my variable with the highest exponent. So here I had 3n squared plus 4n squared. And I know that that equals 7n squared. I'm not changing my exponent because this is saying I have 3n squares and 4n squares. I want to know how many n squares I have all together, and there's 7. So now let's go to the next one, and I'm going to match that color, and I'm going to go with the variable without the exponent. So I'm given a positive 2n. You don't need to put the plus in front of the positive. And I have a minus 5n. So here our variable stays the same. And all I'm doing is adding or subtracting my coefficients. By coefficient, that means the number attached to the variable. So I have a positive 2 minus 5. You have your calculators, or you can know your integer operation rules. And 2 minus 5 would give me -3. Now I'm going to work on the diamonds, which was my constant. So I have here -5 plus 4. And again, you have your calculators, or you use your integer operation rules. -5 plus 4 equals -1. So now I'm going to put it all together. And I have 7n squared minus 3n minus 1. And you can't combine any further because n squared and n, they're not like terms, because one has an exponent and one doesn't, and that one does not have a variable with it, it's just by itself.